Hello everybody, welcome back to the channel. Today we're going to be doing something pretty different from what you guys have been seeing recently. Today I have decided to go over mainly some topics on 8th grade math just as like a preview so you guys know what's like what 8th grade math is going to be like. You can go check out the 8th grade math resources and website for like more information. And yeah, so this video is just mainly going to be talking about like some like important topics that I think we will study. And yeah, with that being said, let's get started. So first of all, we have okay, so these units are not listed in order, but I think we will learn like 5 of these, like the first 5 units during this semester. So anyway, let's get started. So unit 1, equations. Basically, we already know how to solve multi-step equations simply using isolating the variable, like adding, subtracting, or dividing or multiplying to both sides of the equation. And yeah, so that's just going to be how to solve multi-step one variable equations, but that's usually a 7th grade topic. And focus 2 is identify equations that have infinite solutions, no solutions, and only one unique solution. This is an 8th grade topic, I think, because we didn't learn it in 7th grade. So basically, we have these 3 equations. Can you tell which ones have infinite, zero, or just one solution? If we look at the first solution, if we subtract 3x from both sides of the equation, because yeah, we can subtract anything as long as we do it to both sides. That means basically we would end up with 1 equals to 0, which is not a true equation. 1 does not equal to 0. So that equation has no solutions. And if you look over here, divide, if you guys, you may think, wait, if we divide x to both sides, this thing would just become 2 equals to 3, right? And that also has no solutions. But no. Well, you could, if when you're dividing by x, what if x equals to 0? Then you're essentially dividing by 0. And when you divide by 0, you can't divide by 0. So basically, what if x equals to 0? And in this case, it seems like x equals to 0 is our only solution. Because if we use divide by x, then we have 2 equals to 3 for every other value of x. Over here, can you tell what is this equation? Well, first of all, let's use distributive property. This becomes 10x plus 5 equals to 10x plus 5. We find that we can simply do subtraction, subtract 10x from both sides, and we get 5 equals to 5. That basically means that, well, 5 always equals to 5, and yeah, and that obviously is always true no matter what x is. So yeah, that's basically unit 1 equations. And then we have focus 3, which is special case equations. So can you solve absolute value zero products equations? So basically the zero products equations will come in handy when you are doing quadratics. But first of all, when you are solving absolute value equations, you want to consider the cases. Because if this expression over here is positive 3x plus 5, then that means that it will be the same as 3x plus 5. Meanwhile, if 3x plus 5 is negative expression, when you put it into the absolute value, you're essentially reversing the negative sign in order to get a positive answer because absolute values only output positives. So basically then you'd have negative 3x plus 5 parentheses. So yeah, that's things to consider. And you also have to consider if the equation is satisfied under those conditions. If x equals to some value, this has to be positive. If x is like smaller than some value, then this has to be negative. And yeah, And then you also have the zero product property, which you know that everything multiplied by zero obviously equals to zero. Well, you can apply this over here. What if 2x minus 3 equals to 0? Well, that means that you would basically have 0 times x minus 9. Obviously, that's equal to 0 because 0 times anything is equal to 0. And then we can solve for x in which this is equal to 0. Because remember, 0 times x minus 9 is equal to 0, and the right side is also equal to 0. So when x equals to that specific value in which this is 0, then that equation will be satisfied. You can also do the same for x minus 9. And this will again be pretty handy when you go on into quadratics. Anyway, then we have Unit 2, Geometric Transformations. In this case, we uh, already probably learned this in like 7th grade, later 7th grade, for like the accelerated students, at least. So yeah. Anyway, so translation's pretty easy. When you're translating left or right h units, you just add the h. Well, yeah, h is the movement leftwards or rightwards, but in this case, we're assuming right is positive because it is on the coordinate plane. So right is oh yeah, sorry for sorry for the crappy handwriting. So anyway, right is positive. So and left is going to be negative, as you can see on the coordinate plane. So basically, if you have leftwards h, then you would basically be subtracting that value. And then also that also applies to k. If you're going upwards, you add the k. If you're going downwards, you have to subtract the k. So yeah, that's basically what translations is. And then we have focus 2 or dilations. So I think we learned this with like respect to the origin and all that stuff. So basically you'd have again dilation's pretty easy. Just multiply the x and y values by the dilation factor. And focus 3 is reflections. You can probably visualize this pretty well over the x-axis. Let's say this is point A or something. You obviously know the oh my god. Okay, so let's just say this is point A and this is point A prime. So yeah, you can just tell that the first of all the x-axis is the x value is not changed, but the y value is like flipped. Like it's the opposite y value. And yeah, and that's reflections with respect to the x-axis, and you can apply that to the same with the y-axis, except this time x is the one that's being negative. Anyway, finally we have focus 5 rotations. This is probably the hardest focus. I personally think that it's hard to like really visualize and plot without using these formulas, which actually are pretty handy. Obviously, this is for respect to the origin. Just keep that in mind. I think all of these are with yeah, so all of these are with respect to the origin. And you guys, when you're doing these rotations, I recommend you guys all like remember these formulas. So when you're doing rotations, they can come in pretty good. Like you'll memorize them. You don't have to flip the paper or do any of those stuff. And yeah, that's unit 2. Moving on to unit 3. We have system of equations. Okay, so this unit is really where like more of the new material starts kicking in. Because we already know how to solve equations, right? With one variable, just x. But what if we put in another variable, y? Well, we'll see that in order for x plus y, like in order for an equation like that to actually will be solvable or have like a finite number of solutions, we have to actually make it satisfy a system of equations, and that is usually two equations. So basically, you have to find values of x and y that satisfy both these equations. And later on you'll learn and what yeah, later on you'll learn how to use substitution to solve these equations, which I have I have covered in my previous video on AOPS Intermediate Algebra, lesson 1. And so basically you let x equal to, and for x in terms of y, you let x in terms of y, and then you substitute this as a whole thing into this equation, and then you solve for y, and then you solve for x by substituting the y value back. And then you can also use elimination as seen over here, where you basically add up the two equations. So basically you're doing adding x minus y to the left side, and then you add 3 to the right side. Yeah, you can do equations. You can add them up like that. And with that, you'll produce this new equation. Remember, you may think, well, x minus y does not equal to 3. Well, it could not. Well, it usually does not equal to 3. So, well, how do we know these equations aren't equal? The thing is, they don't have to be equal to the original equations. Well, they are definitely a transformation and a manipulation of the original equations, but they don't have to be equal to the original equations. So basically, it's like, uh, how do I say it? So basically a transformation of these original equations by adding these things up. And as you guys can see, if you add these up, y minus y equals to 0, you cancel out the y and you only have x. And then you can just solve for x, and finally you use substitution to solve for y by plugging the x values back in. And then focus 3, we'll apply the same thing that we have done from unit 1, where we'll actually find if the system of equations has, how many solutions. So for the no solutions example, we can first of all divide the second equation by 3 on both sides, because remember that is equal. So you could do that, and that will just basically be x plus y equals to 1. And the top equation is x plus y equals to 5. And obviously, if we just do some elimination by subtracting both equations, then we'll basically get 0 equals to, 4. And that obviously is not right. So there's no solutions. Over here, if you just simply multiply the second equation by 2, you'll get the same result as the first equation. And that means if you use elimination again by subtracting both sides of the equations, and then you'll just basically find that 0 equals to 0, or there's infinitely amount of solutions. So that's unit 3, and now we're moving on to unit 4, where I think, we learned the Pythagorean theorem. I think in 6th grade they actually taught us, or at least I think they taught us about the Pythagorean theorem, but I don't know what's going to be new for 7th grade, and just as a reminder, this is a right triangle. So in this right triangle, we have a squared plus b squared equals to c squared. That's obviously the Pythagorean theorem. It's a classic example. And it's a useful theorem, not just for those who already remembered it, but you can actually apply it in quite a lot of problem solving parts. You can find relationships between like sides, and you can even find heights when you're finding for area. You can construct a right triangle and find a specific height that you need, and also then you can find areas, or you can just find relationships between sides. And then I think we have some applications. So this problem is kind of more of a real life situation. Let's just quickly solve it. I mean, just quickly go through it. It's kind of a cheesy solution. It's kind of a cheesy problem, not gonna lie. So a tree fell from the fell from wind damage at the upper trunk. We can draw a diagram. So this is like our tree, right? And then it got cut, and this is like over here. And this is the tree after it fell at the upper trunk. So it's not at the trunk, we're at the base. And then its upper body, which is this guy over here, lay 3 meters from the where it used to be. So that this is where it used to be. Remember, this tree is straight. So then you basically have this, and we also know the height of the tree is 8 meters. So in this case, we can actually set up a system of equations because we know that this part plus this part is equal to the height of the original tree. So we can say this part is x, right? Because we are finding the height of the tree after it fell, and this part plus this part, or 8 minus x, should be the height of the tree because it's the lower and upper parts combined. And that gives us 8. So this is how we're setting up our equation. Now we can use Pythagorean theorem because this is a right angle. Yeah, we're assuming a lot of things. First of all, and the tree has to be straight. It can't be like tilting. So let's assume this is a right angle. And then you basically set up a system of equations using Pythagorean theorem, like x squared plus 3 squared equals to 8 minus x squared. We learned how to solve these equations later, but then you can solve for x, and then that's gonna be basically, yeah, it. And then you basically just found the height of the tree after it fell. I kind of think these types of problems are pretty interesting, and because it's a real life application of these problems. And yeah, I find it just pretty interesting and cool. Then we finally have our last unit. This unit I think we'll actually go through in more detail in like a separate video. But basically we're graphing lines. So first of all, lines. This is like the main topic, one of the main topics of 8th grade. So yeah, you basically have the slope-intercept form in which M is the slope and B is the y-intercept. Remember, we're graphing a line on the coordinate plane. The y-intercept is where it touches the y-axis, the point where it touches the y-axis, where the slope is basically how steep it is. And the slope is basically you choose 2 points along the way, this point and this point. You measure the y coordinates of these points, and then you subtract them, and then you measure the x coordinates, you subtract them in the same ordeal, like same fashion. You can't do like y1 minus y2 minus y1 and do x1 minus x2. So yeah, in the same fashion, and then that's basically the slope. If you visualize it over here, it's going to be how much the y value has incremented in this right triangle divided by how many the x value has incremented. And then we also have point slope form, which is useful knowing if you know the slope and another point, and then you can just set up the same equation using the slope intercept form. And then we have unit 5. Oh yeah, so the focus 2 and focus 3 are mainly focused on quadratics and absolute values or special cases. Quadratics, we haven't really learned this yet, but if you learn it, I think like later this year, hopefully, we're gonna know something how to complete the square into vertex form. So it's a technique in which you transform and you transform the quadratic equation into, well, an equation that's pretty easily graphable. As you're able to find the special points on the easily you're able to easily access the special points, special lines on the quadratic, and you can just simply graph it. And then for focus 3 we have absolute value. Yeah, we are graphing absolute value. This is very similar to solving absolute value equations. You still have to do quite a lot of casework. So basically you ch- choose the values in which x become positive or x, I mean the expression becomes, the absolute value expression becomes positive or negative, and then you do casework to basically find the equation that in which x exceeds or is smaller than this value does satisfy. And yeah, with that being said, I hope you guys all had a good 3-day weekend, and see you guys next time.